Okay. Basically, we will just have, as I said, a quick look at testing. The idea is to get, as I mentioned earlier, it's about understanding the requirement uh, about the quality assurance, right? So just to ensure that, how to ensure that proper quality is maintained. And as I mentioned, even in the first lecture, it's this is one of the things that are ignored or squeezed, or just go across, just superficially more often than not, right? And could be the reason of many the problems in what you do, right? So as computer engineers, it's not just for this course or whatever. It testing has to be integrated. So that's why as I mentioned, that we are going to have a session on test-driven development. So that to just one of the ways of doing things. We will look at that also, but to ensure that that you maintain or you guarantee the quality of the work of whatever you are doing, right? So more than testing, it's called quality assurance, right? So quality assurance, we need your primary concern in anything you do has to ensure that it's proper quality, right? It's not a matter of building something and giving. So that we will try to look at the basic concerns to ensure that you understand what about the bigger picture, right? And with the hope that you will we won't have, the thing is that we won't have time to do each one of these things, right? But we'll try to cover as much as possible. But more important, as I keep saying everywhere, it's not about what we will be learning here and just gain, but it's about the attitude about that problem, right? So that that if you are keen on ensuring that your work, whatever you build, whatever you design, is of proper quality, right? Then if you take pride in giving a quality product, if you take pride in that you are an engineer and whatever I do will have the proper quality. So we see that quality in your presentations also. Hopefully, so you will develop that mentality that whenever you do something, you establish or you maintain a particular standard, right? And if that attitude, that what you call assurance that you can have, then you will learn everything possible, and you will keep learning how to ensure the quality of your product, right? So that is what is needed. I'm just going to give you like a big overview. Most of the things you might know already, but just to have another viewpoint, because this is something that we see keeps missing from everywhere. So, I mean, when we ask, why we test our code, this is usually the idea is to find bugs, right? So that is like errors, a mistake or something, right? So usually that is we take it as find bugs, right? But one of the key things is that testing can only show the presence of the bugs, right? So not the absence of the bugs. So this is one of the key things that you need to not just understand, it's kind of like internalize, because if you need to realize, it's like what we have now, right? In case of COVID, like, everybody knew when we talk about, you have this many COVID positive patients and not, it was never, it was always mostly about how many are tested and who's tested. Right now, we now, I think, know as a fact now, like if you test people now, I think more than half of the country would be infected now. Probably, I think maybe I am also positive. I had a flu, was down. I was thinking that it was flu. I never got tested, and probably I was positive too. Who knows? And you can see that everybody is coughing these days. So we have no idea, right? But it's like, the absence could be because you have not tested. That is the key thing that you need to understand, right? If you test, if you test and if you test properly, then there are possibility of finding more and more problems. But absence doesn't say there are no problems, right? There's no way that you can give a guarantee to a negative, right? You need to understand this one. Like, there's no guarantee. You can never give a guarantee about a negative, right? So it's not there. How can you say? We don't know. It's the only thing we can say. We have not tested, right? That's all you can say. So that is why it's important to understand how should we test it, what should be tested, and ensure that that you eliminate as many possibilities as possible, so that the probability of error is minimized. Right? That's all you can do. So that is the main thing you need to understand. Like, when you're trying to ensure quality, you want to ensure that the product is it's error free, and it's what you call, it will work as promised, and it will not have unintended consequences. Now, how much of that will work depends on how much you test and ensure each of these things, right? But once again, there's no way that you can identify all the problems, right? So and then these are very common, like, that more common than you think also, right? It's, there are errors that could be there for many reasons, which you need to identify and have checks for. Like, we had things like, Chernobyl, all that, because of human error or negligence, right? And we had issue like, a Mars climate orbiter which crashed on entry. Does anybody know how this happened? Doesn't anybody know that how this happen? Haven't heard? No? Seriously? Does anybody know haven't anybody heard about what happened to Mars climate orbiter? Seriously? That's a shame. Any guesses? I'm surprised that nobody knows. Okay, so this one crashed on entry into Mars, and the reason was that so it was done by multiple companies, and European one and all that. NASA. So, so look at the caliber of the people who were doing this, right? So it's NASA and Lockheed Martin, which is the largest producer of this aircraft, especially military and that related aircraft, right? Lockheed Martin, and European Space Agency, and once they crashed. So this is one after it crashed. Okay, when they were looking for the problem, they only then they realized that they had these systems built by NASA and Lockheed Martin and the European, and then they had used one system had used the metric system, meaning meters, kilometers, all that, right? And the other imperial system, as some of you may know, or all of you know, that in US they're still using the imperial system, right? The feet, inches, and so on, and the volumes, everything is they're using imperial system. So the two parts of the codes were using different systems. Now just imagine, right? We are talking about multi-million dollar project done by the smartest people that we assume, definitely, right? Who put things in mass, right? So there's very smart people, but this is and they fail to recognize one simple thing, right? One part of the software using imperial, one part of the system using a metric. Now the loss is huge, right? And you do this for years. You plan, you design everything, you send it to Mars, and then once it's trying to the land, it crashes, right? So the time that is lost, the money and everything, while employing the best people. So this is what you need to understand, right? No, it's it's a very simple, very simple overlook, right? Just one thing, they have been very, very thorough in every other thing possible, right? Every tiny, minute detail they have gone through and missed a very, very important thing. So this is where the problem is. When you look at the quality assurance, it's very easy to overlook things, right? It's very easy to assume things as not a problem, because absence of an error is very, very difficult to prove. That is the problem, right? So that is one of the things that I'm as I keep saying, that is one of the things that you need to internalize. You need to to understand that things can happen. I mean, these type of things can happen, and there are many other such things Ariane 5, which with loss of 1 billion, right? It's again a software error, right? I mean, we have been having this type of issues for a long time, right? We had one of the biggest things that we had when we started doing. You were, I think, you were just born or something, right? You were babies at the time, or whatever. And then we had the Y2K problem. Anybody know what Y2K problem is?
Yes.
What is it?
Before 2000, they were using that, removing that 19 part, and
yeah. Yeah, it's the same thing. It's the same problem that we are having with IP version 4 and all that. Like, you want to reduce the space. So, like, just using last two digits is enough. Until, maybe around 94, 95, 96, people realize, so what's going to happen once we turn to 2000. Right. And including Microsoft Windows and everything, all the major software, everything, Linux, all those things, everybody was using just the last two digits, right? So these are like the smartest people, but they were not thinking that far ahead, right? So that is also a problem. Like, like you're just not looking at the extendability, sustainability, maintainability, and all those things. So actually, the catastrophe that was predicted never happened because people took measures to fix it. So, but fixing that, of course, cost a lot of money. But ultimately, we didn't have the catastrophe that was predicted because all the systems supposed to stop and not working after that to have. Right? So, but things were fixed, but it took. We had to spend a lot of money to fix it. Right. So there are many things like, this, like, not just that one, because of this software error, and then we had Boeing Max 8, which is again because of a software error. A lot of people died. So there are many issues that can happen if you don't look at the issues that can be caused, right? So how to get rid of software bugs? Okay. Now, so there are many levels that you can do that. Now, what we used to do is or the lowest level is like, basically you run, you go through the code and to figure out where the errors are, right? That is how is still mostly done, right? If you're not really following a proper procedure or proper, you're not using tools that are available or the things are done, right? There are a lot of things that, we used to, I actually, for some reason, started testing my code from very beginning. I wanted to ensure that every part I write was was doing what's supposed to do and not doing things that it's not supposed to do and so on. I don't know where it came to me from, but I used to do that because we started programming, and I programmed a long time with C, and it's like it's a nightmare if you have a bug just to trace and find it. It's a nightmare. So I think maybe that because of that, I used to do all this, go through that one. But the problem is, it's just that so one of the key things again is that it's that when you are writing something, it's very easy to make assumptions that are not there, right? Like what, the same as NASA and Lockheed Martin did. They if you are doing that, you tend to ignore that this change of thing because nobody's expecting it, right? And then you just looking at your thing, you are looking at all the very detailed, sophisticated, complex calculation and all that, but you lose because these are implied assumptions that you have in your head, which makes you have tunnel vision. You're just seeing only one part of it. Rest of the things you just ignore. You have assumption. I try to do this even in courses. I try to show that that when you learn something, there are a lot of assumptions that are there which you tend to forget later, right? So what happens is when you move forward, you take that assumptions as a given, right? But those assumptions are not going to be there. So it's always the case, right? So that you need to know what the assumptions are. But what it's naturally it happens. When you have assumptions, after a while you tend to forget those assumptions, and it becomes kind of like universal truth, which is never the way. Right? So it's very hard to actually look at something and identify errors. And and proving that it's formal verification. So we have courses in a course, couple of courses where we actually look at formal verification. I don't know whether it's done. I think it's not offered this time, right? So we have a course that's called formal verification, but it's that formal verification. It's not really used in practice, because it's like, even to, like, that's it's for a large complex system, a formal verification is nearly impossible to do. I mean, it's good to know to what are the limitations and how far you can go with formal verification, but in practice, in the industry, it's basically never used, for the simple reason that, like, it's too complex to come up with formal verification. But it's that's why I say it's that formally proving that it is correct is very difficult, not always possible. So there are methods to do that, but it's almost never used in practice. And of course, shipping it and wait for them to complain is not a good strategy at all, right? So the idea is to test. Now, when you right? Now the thing is, when it comes to testing, right, there are many things that constitute, right? One is that you need to test for all type of inputs, which you will talk about. And the other thing is that it's that you can do the function at a within an acceptable time, right? And it's basically usable, right? That if your program is not even usable, it's a problem. And it includes not just the functionality, but also the user interface and everything. But how to ensure that is done, right? So all these things, right? We need to test, and then the problem is that that as I keep mentioning, it's that this usually never happens, right? Now the problem is, once again, if you keep, like, so we were talking about this one in the software development life cycle also, especially in the older the waterfall method. If you do the grand design at the beginning and then the bigger development implementation part, usually this development takes a long time, and with the change in requirements and all that, it will also keep getting delayed. And then for the need to finish quickly, now even that you will have even this time, right? Because you will start doing things, and then you will have about 10 minutes to finish. And you will be pressured towards the end to deliver something, right? And then one of the things that you will cut corners on is testing. This is what used to happen in the software industry too. So that's why we have moved to agile methodology, Scrum, so that we ensure that the testing become part of every week's schedule, right? So that's one of the easier way of to do it is test-driven development. We will talk, like, as I said, we will have a session on that one. There are multiple ways. It's not the only way. So this is just to introduce you to that one. It's up to you to test this out and do different things and figure out which one works for you or your project, and so on. But to ensure that ignoring quality assurance, right, is not going to become a part of your process, right? Just because you are pressured because of time, and you are pressured to deliver something, and then just because you kept delaying that one, and that you tend to, like, it becomes a vicious cycle basically, right? And then you you just test some here and there, that you will like, you will not test as much as needed, right? Now, if you look at the bigger picture of testing, there are many aspects of testing. So one of the best things to do is to have the unit testing, right? So this is once again will be the target of test-driven development, to ensure that that each component you do is tested. Now, I don't know why, but as I mentioned earlier also, I learning. I know it take long time to do anything. I think too much on doing things. But one of the benefits of that one was whenever I write code, every function I used to test it, but not automated testing, not like writing test cases or anything. But I used to just test each function for different possibilities. The benefit of that was that when I integrated it, so like this the concepts that we talk about in software engineering, things like writing to an interface, and being modular, and a function doing just one thing and one thing only. So I keep telling you, and even senior batches, software engineering is mostly kind of like common sense for idiots. So this software engineering, all these principles and all that, it's mostly, if you look at the books, read the books, you will see that these are common sense things that if you are programming and if you're thinking about it, it's just for the programmers who just learn a language and become programmers. And those are things that should be inherent for computer engineers or intelligent people like you, right? So it's just like when you think about these things, right? That you should, like whatever, like if you are building something big, when the smallest thing you are doing, you need to have tested. You need to test it, right? So that whether your brick is, it can withstand the strength, the tensile stress and all that. It can, or the crush, whatever the structural integrity of that one, you have to test. The cement quality you have to test. The steel quality you have to test, right? So if you test all these components, then if you get the high quality, proper quality product, when you put together, it should work. The quality should be there. And then when you're preparing different things, whether it's a concrete or whether it's the walls, again you ensure that it is done for the proper quality. You don't wait until the entire house is built or the entire building is built to go and test the quality, whether this is good enough, right? So just similarly, like now you do the unit testing, you test every small possible case, and when you are putting them together, right? When you integrate them, you again test that all components work together. So it's the same principle that applies everywhere, right? If you do that properly, then there's very less chance. There's no chance, right? Even if you use the best quality products, even if you put things properly together, there are things that could go wrong because of things that you overlook. But the things would be minimized, right? So you start from that place, like you ensure that all the components that you use are of the right quality, right? And then when you're putting them together, you test again, right? So if you are testing, if you are designing your software, like you are programming to an interface, right? So each component will have their interface. You don't have interdependencies. So this part produces some, this part gets some input, this part gives some output, and you test it. How you ensure that testing, they will look at, right? And then when you put these two things together, are they working properly? Input and output. And when you do multiple things together, from this one's output to next one's input, from that one's output to the next one inputs, are they all working as intended? So that you test, and then you put everything together. You have to test all the different things, right? As mentioned earlier, whether it's doing the function it's supposed to do, right? So you'll have the functional requirements, whether it's doing the things, right? And the quality test, right? The non-functional requirements, it's not about the functionality, but the other, everything else that comes with it, which will enhance the quality of the product, right? And then you have the acceptance test, like whether the customer ultimately you are coming up with, but whether when you when you look at the customer's requirement, whether those things are all satisfied. So acceptance test could be a subset of the functions or the tests that you have done, right? But at least they conform to their requirement, right? And you have the installation test, whether when you are testing it in something somewhere else, in other cases where you can it works properly, right? So you have all this testing. There are other testing things that are there, which we will discuss as we go. Any questions so far? Okay. Now, another thing is why this is hard. We have to understand why this testing is hard, or it's that ignored, or people tend to have problems. So the key problem is like you have to test as much as possible, right? But as we have already discussed, it's not possible to guarantee a negative. So the thing is to try and test as much as possible, and while keeping the cost down. Now, when you say cost, the economic cost, like it's if you develop a software and you if you want to test for another few months to test all the cases, all the possibilities to ensure its quality, then you are losing money during that time. So you need a trade-off, but what is the trade-off? Now, I will come to one of those things later when I'm discussing, like and the idea is that find the faults cheaply as quickly as possible, right? I mean, ideally we can come up with one test cases it will expose, but it's never possible, right? Because what usually happen in testing is that we will run we will have to run many unsuccessful test cases that do not expose any faults, and that is like that's a okay, I'll come to that. As I said, when we're talking about regression testing, actually. Now, when we like, the biggest problem is how to design the test cases, right? Because exhaustive testing, of course, is not possible, right? If you look at the variables, there are too many combinations. I mean, just to give an example, if you have like a program with 3 inputs, which are ranging from 1 to 1,000, you can just have 1 billion different test cases, right? But that you should already know that that is I mean, that is still stupid, right? You are not going to do that. That is not really needed. and so the idea is to identify how to come up with the lowest number of possible test cases, right? How to have the minimum number of test cases while ensuring that you're covering everything possible. Once again, there's no guarantee, but we try to cover as much as possible while ensuring that you're testing for all the possible scenarios, right? So one of the higher level things is, of course, as I assume you already know, is look at the black box and the white box testing, right? Do you know? I assume you have done black box and the white box testing, right? Yes? No? Have you done white box, black box testing previously? Hello? Yes? No? Have you done white box, black box testing? Have you learned about it? Hello? Okay, I'm going to pick somebody and ask. Okay, Akila, have you done?
We've learned about it, sir.
Sorry?
We've learned about it.
You have learned? No.
We have learned about it, sir.
Okay. Yeah, that's should have been easy to say that, right? Yeah. So the idea once again, right? So the idea once again, you know, as you have done, I'm not going to go into detail, but once again, okay. Have you done? We have learned about it. Have you done this testing? White box testing? I don't think. Have you done things like, you know, code coverage and so? I think you have done code coverage, right? Is code coverage would have not have been easy to do in 3 maybe. You have not done code coverage, right? Have you? Can somebody answer?
No.
Okay. Right. So black box testing is, of course, much easier because your focus is to look at, as I was saying, about the input-output behavior, which is much easier to do because you look at the interface and then do it, right? Now, one of the key things, so like normally code coverage, like, you know, like white box testing will come later. So white box testing is kind of something that we do, it should be done. But at the least in the black box testing, what you're saying is like, you know, when you give a certain, when you're giving a certain input, whether you're getting the output, the expected output, and then when you integrate, whether that integration that also happens properly. So like unit test level, you can do the black box testing, right? For a given input, are you getting the expected? Now the problem once again, right? It's the okay. I had a comic strip here, which is, I don't know why it's missing. So so the idea is not just to test, like the biggest mistake people do in black box testing is that they test for whatever that is in your head, so that you think that you design a software and then this is the type of input that you can get, right? And you test for those things and it works. It's great. The problem is you are not you are not testing for all the possible cases, right? So this is where we say that, you know, when you look at the input, like, you know, if you're looking at the right output for a given input, you cannot test for everything, but you reduce it to reduce the number of cases. So how you do it is what we call this equivalence partitioning. You look at the input and then look at the input conditions and divide it to equivalence classes, right? And identify test cases for each equivalence class, right? Now, what do you mean by this equivalence classes? Is just that you have to you have to look at the input, look at the valid input cases, right? And then you look at the possible range. You look at the what happens to the input below that range. What happens to the values above that range, and what happens to so your functional requirement should be within that range. But what happens if it's below that range or above that range is one, right? And then if the input is invalid, right? So there's a comic strip in an CD where you have a name of a kid set to given a value which is actually tend to delete the entire database table. So this I hope you have seen it, but I'll share it as well. So the thing is that input validation, if your input, if you are expecting a number, what happens if you get a text, right? And you are expecting a certain value, and normally what happens, people, when you're testing is they just test for that particular value, right? Like whether it's working, it's functionally it's working. What happens, whether it is for example from a user input or input from another function, rather another unit, if the input is in the wrong, basically what happened to mass orbiter, right? You are getting an input, whether it's in the right the metric, right? So those things you need to test, right? Is it valid? And what happens? How does your program handle that one? So usually, if it's maybe because we started working with the Linux kernel things and all that at that time, even if it's a very small C function, maybe that's where I got that use from at that time. But if you have a very it's doing just one function, but the function would be very long, because you ensure that your input is validated, and then you have all the ways to handle it gracefully, right? If it's possible. It's unless you have things divide by zero and critical cases where it could lead to segmentation fault and all, of course you'll have to still, if possible, exit gracefully without crashing. But you need to look at all the possibilities, catch all these input errors, right? Input validation, and only go to your functionality if you are getting the right input, right? Now this is something that I you see missing from a lot of programmers, and definitely people who just learn programming language and program, right? So that is one of the things that you need to ensure that you handle. And then the other things are the boundary cases. Now this is this is some place where most people, even in computer science, computer engineering graduates make mistakes of of course programmers make more mistakes than that, but especially since we start counting with zero, and others are not familiar with that one, or not geared to that one, the boundary conditions, because less than n or less than or equal n is a mistake that people do in a lot of places, right? To ensure, because of the combination of these two, right? You start counting with zero, and then you can mistake with equal or less than or equal. Less than or less than or equal, right? So these small things, right, could make a big difference because you are not looking at the boundary condition. So you can have within the range, outside the range, and also boundary conditions. So you need to ensure that you are testing for all these things, right? You ensure that you are actually doing, like, when you run, is it working for the given cases? Is it working for the boundary case? Is it not working? Is it guaranteed to not work for the things outside? Right. So these are the things that. So it's once again, it's simple, right? You pick things outside, you pick one test case inside, and then in the boundary condition, you're done. Right. So when it comes to that, and the benefit is that you're not looking at the implementation details. You don't have to worry, right? And once again, like we were discussing with the abstraction modularity, you don't have to worry about the changes to the implementation, right? So that is, of course, one of the other things that we don't have to intended consequence also, right? You're not worried about the implementation. You just see whether that is doing the function it's tend to do. But on the other side, the problem is in black box testing, you are not testing all parts of the program. So that's where the white box testing comes in, because in white box testing, we go with what is called a thoroughness, or the code coverage. Right now, when it comes to white box testing, there are different types of testing that comes with white box testing. You can basically the number of statements that has covered, and then the loops. Are they working properly? Are they going through the entire thing? And the looping, as well as the exit from the loop, and then when it comes to those things, and the either whether it's the looping or the if-else statements or switch statement, whether the branching happens properly, right? And different paths are whether they are followed. Now, what happens is, usually what happens is, you have this what is called a 80-20 rule in software, right? 80-20 rule, which says that 80% of the time, 20% of the code will be run, right? Now, just to give you an example, now I was when I was working at Cisco, so I was I was a quality assurance. I was software engineer, software QA engineer. So we were doing. So I will talk about that one also. I was mainly handling. I was handling new functionality as well. I was also. We had to solve a problem of regression testing. So regression testing is like, ensure that all the previous functions are working properly, right? So whenever you introduce new thing, when you have update, you need you do the regression testing to ensure that all the functionality that has come up to now is working as it's supposed to. I was at Cisco Security, and we had the regression testing. So it's all an automated test suite that as soon as you have a new update or new version or new release, that you do the functionality and other testing, and then also you run the regression testing. So usually these other testings usually finish within 1 or 2 days. But in security, Cisco Security, in our the regression testing used to run for 5 days, and it's a long time, because then your release of software actually get delayed by 5 days, because it's not just 5 days, but it takes 5 days for the testing, and then of course you have to compile these reports and send it up the chain, and then do check all these things, give the go ahead, and it takes it takes a once it is really released internally, it takes a long time to release go out. And in our regression testing, it was taking about 5 days. So I was asked to look at, and then specifically about from our product, our part of the things that we were actually doing. So I was asked to look at that one. So what I did is actually since I could not work with the production system, I set up an entire test bed just to run these cases to inspect in detail about what's happening. So one of the things, so earlier, like the beginning, I was of course looking at a higher level from the outside, and then I realized there were certain things which were not matching, certain things which were very suspicious and all that. So of course there were a lot of issues. So which anyway, ultimately I managed to find a lot of issues and bring it down to 2 days. From 5 days, we brought it down to 2 days, identifying many issues and finding solutions for that one. So one of the key things that I found is that it's like where we had problems is about this code, not about the code coverage. Actually, we introduced code coverage later. Code coverage was there already, but people were not following the code coverage issue. So one of the things that I found is that there was this couple of, so we had multiple suites in that testing. So there was one suite that was actually not failing any time, and it was causing problems. It was getting crashed, but all the tests, like when I looked at the results, it was passing all the results, but it was it was always stopping in the middle, and nobody knew why it was. So you had to restart and run it again and again. But in the end, it almost never had any failed test cases. So it's just that it never ran properly. So then I was very suspicious about that one, and it was written in Ruby and Water. Water is like a wrapper to Selenium. So I had to learn that one, and I went inside the code and checked one by one all the code coverage. And actually, I was not happy with the code coverage tools at the time as well. So I actually did manually. I tested different. One of the things I found is that this test cases, finally it went to a function which just output true as its results. That's all. So whatever way, so that's why all the test cases were that's why all the test cases were passing, because it was doing a lot of many different things. It was going to do in that one and this one and that one, and it's like every test case would go in a different path. But ultimately, almost all the test cases ended up in a function deep down the code, which just returned true. So whatever happens, all the test cases passed. But because of that one, things about things are not going well. But you never get a wrong things. If you end up in that place, that is where you go and end up ultimately. It will give you true. So why it was written and all that, we don't know. It was done by a Ukrainian team actually. So we didn't know why it was done. They said they messed it up, or they didn't know. But it was there. So everything was passing, and everybody was happy actually. It's like my manager didn't want me to go and dig it up, because she was saying no, we're gonna open a can of worms and all that. But the problem was, since it was not finding the errors that are above, every other place it used to crash if there's a problem, because you're not identifying issues, right? Now these things, so that after that, the code coverage became again a high priority thing to do. So just imagine, this is Cisco, this is like the biggest network company, right? So of course NASA is doing the same, errors and all that. So it's no wonder these places also, they do these things. But this is very common. That's why I want to say, having these kind of errors, having these kind of issues are common, because it's like their problem also, they had not done the proper testing from the beginning. right? They had just ignored at that time. And then later trying to integrate this into the picture, they were never catching all the problems, right? So that's why once again, that you need to start doing these things from early, like all the possible, like, branching. If what I mean, if there's a branching, does it work as it's supposed to do? Okay. And so the code coverage will ensure that you are actually going through each part and it's working as it's supposed to do. And if there are certain parts which are never reached, then you need to know why it is so, right? So so you do all this testing, like loop testing, path testings, right? Branch testing and all that. So what if you do that one, actually you ensure the quality of the, you ensure that nothing goes wrong in a very rare case, right? So the Mars orbiter crashed when it was trying to land, right? So these type of things, it's like, if you like, the Boeing Max 8, it crashed on a very like a particular instance, right? I mean, it's not possible to test all the things, that's for sure. But when you are doing code coverage, if you do code coverage, then you can actually ensure that there are no unintended consequence. Even like that is where the biggest problem is. Even if you ship it to the customers, they won't see they won't see failure. Like unless all the stars are aligned and so on, right? So the code coverage will provide you, white box testing will provide you with that one. At least at a certain level, you need to ensure that how much of the code is actually run. What happens if I get a input in that will go in a different way, right? So that if you test that one, you guarantee the quality at a much higher level, right? So as I said, you have to test for both the success and both failure, right? Because then only that you can, like, most of the times what happens is people test for success because what is expected. You just test for these things, whether it works fine for this one. And then if it's not tested for bad inputs, right? It could happen that the user will give a wrong input, or it could happen that somebody, when they are extending this one, when they are extending your software, they will write a program without really looking at what you are testing. Because like if you are not specifically said what's the input for this one, or they can make a mistake and send you wrong input. Who knows? Either way, your system is going to crash, going to run into problems if you are not testing for bad inputs or the failures, right? So you need to be aware of this one. And then, of course, the automated testing, this is what we are going to look at in the things that, rather than doing this again, and then we will try to look at, so the Keshara will do how to do the test automation with the Azure DevOps. We'll also look at, test-driven development, which will actually more rigorous way of doing to ensure that things are done to for the requirement that is there. Say that anyway. That session is on Friday, so you can look at that one. It's not a must to do TDD, but you need to do it. One of the ways, right? You can have the test, but the testing has to be an integrated part of your development. So that's one of the things that we will check in your presentations, in your final evaluations also, to ensure that you have done it one of the ways. We are not going to, as I said, we are not going to force you to choose one, right? You look at these possibilities and pick how you're going to do it. Okay. But it has to be automated so that you're not going to so whenever you do something, these things the testing will be done automatically. So it becomes part of that. So becomes part of the agile process, right? So you change something, you test. So this is like, as I said earlier, Regression testing, it's like one of the biggest things. Like, so the regression testing is that you do the functional testing, right? You introduce new functions. So let's say that, you know, when we are introducing a new feature into a software, right? You have to have the functional testing, right? So you test whether that function is working properly. So you will be doing the unit testing for the different parts. The developers will be doing the unit testing, right? So the developers are usually doing the unit testing to ensure their individual components are doing what it is, and then they will also do these things like the integration test and all that. And once that passed, they will put it to the system, and that is where you will actually do things like continuous integration, right? So that's also will be handled by Keshav will be doing that in DevOps, Azure DevOps. So this continuous integration and all that, every time when you're doing this, you will run that automated testing, and then any new feature, once that is tested and that is passed, and then you go to the next iteration, this part of course becomes part of the previous functionality. Now the idea about the regression testing is when you come up with new features or some update, all the features should be working. Like, say for example, you have a software which is working and people are using, you come up with an update. If any of the previous features stopped working, that's a problem. Your new feature, while it is important and will be a value add to the existing software, not having that is not a problem for the users because they don't have it yet, right? But if when you introduce something or you fix a bug or whatever, and something that you have, like something that was working earlier stopped working, then everybody's going to panic, right? So usually what happens is regression testing. Like if you have a failure in the regression testing, you just stop it. Just like, I think when I was there, it happened only 2 or 3 times that you complete, like, and it becomes completely like, you just stop dead on your tracks. You stop, everything is reversed. That's done, because you cannot move forward. If the regression test is failed somewhere, you just stop everything, and that is thrown out of the, like, it might go back and somebody did to test what's happening, what happened and why and all that. But that's it. You're not shipping it. As it is, you're not shipping it. That's it. There's nothing. And even regression testing, you have, parts like, just like smoke test, sanity test, all that. A smaller part of the regression testing to ensure at least the bigger parts are, like, at least the most essential parts are working. If you want to do, like, rapid releases and all that, to at least to ensure that, this beta version and all that. So, like, you beta testers and all that, you will at least do a smoke test, sanity test, just to ensure the major parts are working. You won't have the elongated regression testing because that has, like, a very long set of tests to run. So that will go early to testers. So for maybe some part of the customers, while you will do the longer testing and even with the beta testers to ensure that the rest of the things are found, right? But regression testing is one of the key things, so that all the tests that you add goes to this automated test part, where you will actually test every update. You run the rest of the tests to ensure that nothing that was working earlier is broken. Okay. So unit testing, of course, we have worked and all that, right? So I'm not going to go into that one. And then unit testing, you have features, like you have tools that are specific to different programming languages that you use, like JUnit and all that. So that those things I assume you have already used and you know how to use, right? So you need to look at all these things. Once again, as I said, testing is an integral part of the development, and we want you to follow the quality assurance rather than saying testing. Quality assurance, we will be looking at the quality assurance of the software very, very thoroughly, right? So pay attention to that. But as intelligent engineers already, like, doing well, we are not going to dictate this is what you're going to do, right? So you can look at the different things. like, there are all different ways of achieving the same thing, right? So we're not going to dictate how you're going to do it, but pick one and follow up with it. As long as you have followed the process, you are good to go. But pay attention. We will be we will want to know the thought process behind your testing and how you have done that and all that in the evaluations. Okay, so we will be paying a lot of attention to that, right? So doing test-driven development will makes things easier. That's why we are introducing test-driven development, because then you won't have to, like, since it's a process, it will ease you to forget about the testing part, because you'll be doing everything based on that and focus on the product, while the testing requirement is already, like, automatically ensured. But it's up to you. So know that we'll be testing on that, and pay attention to that. And we'll have that session on Friday by Mr. Tarindra Jayamaha from 99X. Okay, so be ready with your questions and all that. Try to get as much as possible about the implementation, usage and all that, because that will, rather than just the big picture like what I did today, right? To get to know how to exactly do it, implementation, because that's going to be important, right? So try to extract as much as possible from that as well. Okay, so we will stop today's session there. Okay, Keshara will be sharing with you the details about Scrum and the plan, and what we are going to evaluate and so on. So follow the schedule. But one thing to say that is that it's your responsibility to get all the things done, right? So to coordinate with your Scrum Master, get your Scrum Master to work for you. So that is your responsibility, because that is their task. So you can get your Scrum Masters to do, like, coordinate with the product owners and find the time slots and do that. So giving you those things planned and arranged, as well as if you want any other the computing resources and all that, making sure those things are arranged as well. It's the role of the Scrum Masters. So you can work with them. You can directly work with the product owners as well, right? So, but ensure that you don't delay things. You get things rolling, so that you can actually come up with the good product and results by the end. Okay, so it's your responsibility. We will try to help as much as possible, but remember that it's ultimately your responsibility. So don't just wait until we ask you to do things. Start doing, and hopefully we can have very good products by the end. Okay, all right. So we'll wrap it up for today, and I'll see you later.